As we move into Chapter 3, we have to recognize an important idea. That so far, really what we've been talking about is this kind of foundational idea of Calculus 1, which is limits. Remember, if anyone was to ever ask you, what is calculus all about? Your answer should be limits. However, one of the main goals in Calculus 1 is to develop mathematics that's necessary to find a tangent line to a curve at a point. And limits have just been a tool that we've been developing to really help answer this question. So we're going to give an intuitive definition right now for what a tangent line actually is. And we'll see in example 1 what a tangent line might actually look like. So let's start with the intuitive definition. A tangent line, or what's sometimes more commonly just abbreviated as a tangent, to a curve is a line that touches the curve. A tangent line should have the same direction as the curve at the point of contact, and a tangent line should do a good job of approximating the curve near the point of tangency. Okay, so we're going to try to go ahead and visualize tangent lines in blue today and see kind of how exactly this compares to another definition, which is for a secant line. A secant line is a line that will intersect a curve more than once. Okay, so let's go ahead and try to see here how these two things compare. In example number 1, I'm going to try to sketch a line to each curve or a tangent line to each curve at the point of P. So really quickly, just going through each of my pictures, you'll see that sometimes I have functions and sometimes I don't. So like my circle here is not a function. But my other curves here are functions. And you can see on each of them I have a point P that I'm kind of highlighting here in black. Now if I wanted to draw a blue tangent line, it would need to touch the curve at the point of P. But it should be moving in the same direction as the curve at that point. In fact, it should almost look the same as the curve, really close to this particular point. So if I was going to draw a tangent line down here on point P, I would tend to try to draw something kind of in the following way. Notice if I was imagining moving along the circle, say in this direction, moving clockwise, and when I reach this point, if I was to, instead of following the curve, move in a straight line, you could see that I would probably move in a space or in a direction like this. If I was moving the other way around the circle, going counterclockwise, and at the moment I hit the point P, I started moving in a straight line, I would actually probably start to move in a direction that looks like this. So this here would be considered a tangent line. Notice it moves in the same direction as the curve at that point. It touches the curve at that point, and it does a good job of approximating the curve near that point. Notice if you were to kind of almost zoom in here on like a little window, you could almost not tell a difference between the blue curve and the green curve itself, right? On a small enough window, they should look identical. So let's go ahead and see if you can try to sketch out some tangent lines on the next two pictures. Go ahead and pause the video really quick. See if you can sketch a tangent line. And when you unpause, you'll see me sketch some tangent lines on here as well. Okay, well hopefully you went ahead and sketched them. If you took a look at this first one, you could see a tangent line would maybe behave something kind of like this. Notice that this tangent line is actually also a secant line because it's going to intersect the curve a second time. And that's totally okay. These aren't two different types of lines. They're just two different descriptions I can give to a line. I can see over here on point P, I would maybe create a line that looks something kind of like this. So these would be some tangent lines that I could sketch. And our goal is going to be to try to figure out in this section what exactly are the equations of such lines. Now before we get to answering questions like that, I instead have a different question for you to try to think about. What would a tangent line to a linear curve look like? So let's suppose that I had a function that say looked like this. And I put a point P on it, maybe right here. Can I come up with what a tangent line would look like on a linear curve? Remember, it's got to touch the curve at the point P. It's got to move in the same direction as the curve. It's got to approximate the curve well near the point P. Well, actually, it's kind of funny. you would draw a blue line that would look pretty much exactly the same as the black line, right? Because if it's going to move in the same direction, if it's going to move in the same direction, it's got to kind of actually cover exactly the line itself. So that's kind of an interesting idea. Tangent lines can actually be the same as the function that they're modeling if that function's linear. So in the next videos, we'll start to focus on, again, how am I going to find the equations of these lines? Hopefully we remember how exactly we write the equation of a line, but we'll recall that at the start of the next video.